Okay, this is a video, an intro video to B2, our expectation, that is called Characteristics of Linear Relations. Okay, so let's start off with looking at a graph. So here in green, we have a x-axis and a y-axis. We've got 4 quadrants in this graph. We would call this quadrant 1 up here. And then we would call this quadrant 2. Sorry, I'm using like Roman numerals because I feel like that's what they do. That's quadrant 3, and this is quadrant 4. In quadrant 1, you'll notice, whoa, everything's positive. So like the x's are increasing on the bottom here. Like this is always 0, 0. And then the y's are increasing over here. So quadrant 1, we're going to use a lot. So up here, because that's like our positive quadrant. And then, as you know, on this side, the x's get negative, and down here, the y's get negative. So just so you know. We call these things right here, we call them coordinates or points on the graph. And if we wanted to graph them, we always do them, it's like alphabetical. So x comes first, then y. So we go left and right first, and then up and down. So if we had to plot 3, 2 on a graph, we would go over 3 to the right and up 2, and that would be our point, 3, 2. If we wanted to plot negative 1, 5, we would go left 1 and up 5. And that would be the point negative 1, 5. Okay, another way to organize points is to use a table of values, where we would have a column for x and a column for y. So like the point 3, 2, negative 1, 5, just a way to organize your points. Okay, let's take a real life scenario here and see what happens. Okay, you're going bowling. Okay, let's say shoes cost you $3. And it costs you $5 per game to bowl. So this shoe cost here, the $3, you have to pay that even if you don't even bowl. Maybe you buy your shoes and then you're like, I don't want to bowl. You still paid for your shoes. And then this game cost, you just have to pay when you play a game. Okay, so let's say we wanted to graph this relationship. We wanted to see like, how much would it cost over time? So we want to graph like the cost to go bowling. And we also want to graph the number of games that we're going to bowl. That's what we want to graph. So like how much is it going to cost if we play 1 game, 2 games, 3 games? So these are our 2, what we call variables in this situation. So one of them is going to be our independent variable, and one of them is going to be our dependent variable. So which is which? Okay, so I'm saying independent guy is going to be the number of games that we play, because it doesn't really matter. Like we decide how many games we play. Whereas the dependent variable, the cost depends on the number of games. Okay, so I'm going to put the number of games on the left side of my table because it's my independent variable. So when I go to graph it, it will go on the bottom. Sorry, I'm using that like hashtag. It's like not a hashtag, it's also a number, short form for numbers. Number of games, that's probably not really good to use though, eh? I should actually write number. Sorry, I'm being lazy. Okay, and then I know that cost is going to be my dependent one, so it's going to go here. And I'm going to write it on my y-axis or my vertical axis. And that's going to be in dollars. Okay, so now if we wanted to create a table, we could create a table. So we would make up the number of games. So my x-axis here, I'm going to say, what if we play no games? What if we play 1 game? 2 games, 3 games, 4 games. You just make up those numbers. Instead of doing 0, 1, 2, 3, 4, if I wanted to, I could have done 0, 5, 10, 15. See what I'm saying? You decide what goes there. Your call. I'm going to go up by 1. And then you see how much it costs. Okay, so we're getting some shoes. Every time we have to get shoes, and that's going to cost us $3. So we're not playing any games. We got 0 games, but we still have to pay for our shoes. So that's going to cost us $3. Okay, now what if we play 1 game of bowling? So think of it as a separate scenario. Okay, 1 game of bowling would be $5 plus my shoes, $3. So if I just go to the bowling alley and play 1 game, that's going to cost me $8. Okay, new scenario. Let's say I go to the bowling alley and I want to play 2 games. Well, $5 per game, so now I'm at $10 plus my shoe cost, $13. Okay, another situation. We want to play 3 games of bowling. $5 per game, so $5, $10, $15 to bowl, plus your shoes, $18. Okay, last one. We're going to play 4 games. So now it's $20 to bowl, plus your $3 for shoes, so $23. So this is just like a way to organize our findings in a table. So now you can see like how much it will cost us at the bowling alley depending on how many games we want to play. So that's called a table of values. And now we can take that table of values and we can graph it. Okay, so number of games is on the bottom. Remember, I always start my graph at 0. Now I need to make a scale, which obviously I'm going to go up by 1s, but I'm just going to skip a line just to space it out. Whoops. I'm just going to keep my numbers going even though I actually only went till 4. Okay, and then my cost. I got to pick a number to go up by. Like, let's say I went up by 3s. 3, 6, 9, 12, 15. I think I could. Or what about 2s? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Yeah, I could do 2s. Okay, I think I'm going to do 2s. So you got to pick a scale to go up by a number. 2, 4, 6. And make sure you go up by equal amounts every time. Don't do anything crazy. And I just did. 10, 12, 14, 16, 18, 20, 22, 24. There you go. Cost and number of games. Okay, next. We got to plot our points. So, going down our list, if we play 0 games, we still have to pay for shoes. So 0 and 3 would be right here. Next, if we play 1 game, it will cost us $8. So 1 game, $8. If we play 2 games, $13. So 2 games, 13. 3 games will cost us 18. And finally, 4 games will cost us 23. So where's that? Here. Perfect. So we can see our points are going right up in a straight line. So in our scatter plot days, it looks like a positive correlation. As the number of games increases, so does the cost. Okay, awesome. So that's how you make a table and a graph from a scenario. A bowling scenario, we made a table and we graphed it. We could even connect it with a line, I guess. I mean, I don't know if you need to, because once you connect it with a line, it seems like it wouldn't make sense anymore, because, like, could you play half a game of bowling? Probably not. But, I don't know. There you go. Okay, this brings us to our next topic, first differences. So first differences are when you calculate the differences in the y values. So differences in the y values. So look at my y value. I just made up 2 random tables of values. I don't even know what these are for. I just called them x and y. Okay, so if I look at my y values, I try to see like, between 5 and 7, what happened? Did it go up? Did it go down? It went up. 5, 6, 7. It went up by 2. Okay, what happens from 7 to 9? 7, 8, 9. It went up 2. What happens from 9 to 11? 9, 10, 11. It went up 2. So these are called first differences. They're the differences in the y values. It tells us what the y values are going up or down by. Okay, let's check the next table. Okay, 2 to 4, it's going up 2. 4 to 8, that's going up 4. 8 to 16, that's going up 8. So these are still called first differences. Notice in the first table of values, they're all the same. And in the second one, they're all different. Hey, let's check out the first differences of our bowling game. Whoa, I just lost it. Okay, here it is. Okay, our bowling game, what color should I use? Blue? From 3 to 8, 3, 4, 5, 6, 7, 8. Looks like we went up 5. Then from 8 to 13, looks like we still went up 5. 13 to 18, up 5. 18 to 23, up 5. So these, again, like I just said, are called first differences. And guess what? When they're all the same, like these are, when they are the same, it means the relationship, sorry if my pen is making like the loudest sound. Oops, the relationship is linear, which means a straight line. And you can see these totally form a straight line. So the use, I guess, the purpose of the first differences is to tell us if a situation is going to be linear or nonlinear. So I'll just add that. So I guess it determines, I'm going to say linearity. So if something is going to be like a straight line or if something's going to be like a curvy line. So looking at these examples, since these are all the same, that would mean that this relationship is linear. And since these are all different, 2, 4, 8, these ones are non-linear. So if you graphed those points, it would not make a straight line. So that's good to know. Okay, so that brings us to our last point, which we already made really. But I just want to emphasize, if you have a graph, a linear graph means it's a straight line. If you have a graph, sorry, these lines aren't straight, a non-linear graph would be like something that's curved. That's non-linear. So anything that's not a straight line is non-linear. Linear means straight line. Okay, and that's it for this video. Thanks for watching.